Sathyabama Institute of Science and Technology.
Hi sparkling learners, wish you all a very great day from Dr. A. Viji Amutha, Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. Glad to meet you again in this video lecture. Today we are going to discuss how to solve a recurrence equation by forward substitution method. As you all know, a recurrence equation can be solved by either substitution method or Master's method. So these two are the widely used methods. So substitution method can be again categorized into forward substitution and backward substitution. So today we are going to discuss this forward substitution method. So this method makes use of an initial condition in the initial term and the value for the next term is generated. So the process is continued until some formula is guessed. Thus in this method we use recurrence equations to generate few terms. So this is called as forward substitution method because here we substitute recurrence of any term into the next terms. Let us solve an example recurrence equation now using forward substitution method. So the given equation is T of n equal to T of n minus 1 plus n. So the initial condition is given as T of n equal to 0. So let us now have n equal to 1 and substitute in the given equation. So if n equal to 1, the given equation becomes T of 1 equal to T of 0 plus 1. So the initial condition T of 0 equal to 0 is already given. So this is equal to 0 plus 1, which is equal to 1. Now let us substitute n equal to 2 in the given equation. So the given equation becomes T of 2 equal to T of 1 plus 2. So the value of n is 2. So this becomes T of 1 plus 2 and the value of T of 1 is generated in equation 1. So the value of T of 1 is 1. So 1 plus 2 equal to 3. So if we substitute n equal to 3 in the given equation, the equation becomes T of 3 equal to T of 2 plus 3. So T of 2 is already generated in the previous term. The value for T of 2 is 3. So this is equal to 3 plus 3, which is equal to 6. So now we can guess some formula. So observe all the previous equations, that is T of 1 equal to 0 plus 1, which is equal to 1, and T of 2 equal to 1 plus 2, T of 3 equal to 3 plus 3. So when we observe all the previous equations, we observe that it is the sum of the previous term plus the current term. It is the sum of the previous term and the current term. That is T of 1 equal to 0 plus 1, T of 2 equal to T of 1 plus 2, that is the previous term value plus the current value. What will be T of n now? So T of n will be equal to T of n minus 1 plus n, that is the previous term value plus the current value. That can also be written as 1 plus 2 plus 3 up to n, that is the sum of the previous terms 1 plus 2 plus 3 up to n minus 1 plus the nth term. For this is actually the sum of natural numbers and we have the formula as n into n plus 1 by 2. So the sum of the natural numbers is given by this formula n into n plus 1 by 2. So when we multiply inside, we get n square by 2 plus n by 2. By ignoring the non-dominant terms, we get only n square term. So therefore we conclude like T of n equal to big O of n square. So this is the time complexity of the given equation. Shall we solve one more example? So the second example is given as T of n equal to T of n minus 1 plus 1. The initial condition is given as T of 0 equal to 0. So here also we proceed by the same procedure. Substitute n equal to 1 in the given equation. So the equation becomes T of 1 equal to T of 0 plus 1. So there the constant remains unchanged, isn't it? That 1 remains unchanged here. So T of 0 plus 1. The initial condition T of 0 is equal to 0. That is already given in the question. This becomes 0 plus 1, which is equal to 1. This becomes equation 1. Now when we substitute n equal to 2, the equation becomes t of 2 equal to t of 1 plus 1. T of 1 is already got in the previous term. That is, the value of t of 1 is 1. So 1 plus 1 equal to 2. So this becomes equation 2. So now substitute n equal to 3 in the given equation. So t of 3 equal to t of 2 plus 1, t of 2, the value of t of 2 is got in second equation, which is equal to 2. So 2 plus 1 equal to 3. So by observing these equations, so we guess a formula for t of n. So what could be t of n? So observe t of 1 equal to 0 plus 1, which is equal to 1. So t of 2 equal to 1 plus 1, which is equal to 2, and t of 3 equal to 2 plus 1, which is equal to 3. So you observed all these terms, t of 1 equal to 1, t of 2 equal to 2, t of 3 equal to 3. So what will be t of n? So absolutely t of n will be equal to n. By observing the above equations, we can say that t of n equal to t of n minus 1 plus 1. So what will be t of n minus 1? It is n minus 1, because so in all these terms we get like t of 3 equal to the previous term plus 1. So the value of previous term is 2. T of 2 is 2. T of 1 is 1. So the value of t of n minus 1 will be n minus 1 plus 1. So minus 1 and plus 1 gets cancelled and we get the value as n. So here we conclude like t of n, the time complexity of the given recurrence equation is n. So it is a linear time complexity. So that's it, students. So the forward substitution method is actually very easy. Okay, we try to guess some formula and then we predict the outcome. So hope you enjoyed the video lecture. Thank you for listening this video lecture patiently. See you again in the next video lecture. Thank you all.